We're starting off the week with a power objective PO22, rewriting equations in slope-intercept and standard form. We actually had this objective or one very similar to it last year. I think back to CO35. Last year was a regular course objective. This year it's a PO. And it involves us going from one form of a linear function equation to another, because every form tells us something different. We're very familiar with slope-intercept form. That's the form of the equation we graph from. It tells us the slope, tells us the line-intercept, everything's there for us. We also have point slope form, which we'll talk about soon. But the focus for today is going to be standard form. Is that flickering light on you? Yeah? If we turn off one of them, is that going to fix the problem? No, it doesn't get very, very dark. We'll see. Is that good?
Keep that.
Yeah, I think that should be fine. I think it turned off the outside ones.
Oh, I get a little sleepy in here.
Oh, you'll be fine. Okay. So slope-intercept form. What is slope-intercept form? Maggie, what is slope-intercept form?
It is 1 second. Y equals mx plus b.
Y equals mx plus b. Okay. Standard form, if you recall from last year, looks like this: ax plus by equals c. Does that ring a bell?
No.
Ax plus by equals c. Well, if not, then here we go. What do you notice about those two equations? Compare, contrast. How are they alike? How are they different? What sorts of things are you noticing here? Lauren. Really, the only difference between these two as far as the position of the variables is that in slope-intercept form, y is by itself, and in standard form, x is on the same side as y. That's basically it. Okay? So good. That's going to come into play when we start to convert back and forth. Just kind of noticing where our variables need to be in one form versus another. What else do you see? Similarities, differences? Last class pointed out, I want to make sure I highlight this, that both of them have a b, right? Y equals mx plus b, and then ax plus by equals c. But notice that one is lowercase and one is uppercase. That is because this b in slope-intercept form is not the same value as the b in standard form. For example, you don't write this down, but if we had an equation, y equals whatever slope and a b value of 2, it doesn't mean that in standard form it would be 2y, because that capital would be there. The reason why one's lowercase and one's capital is because they're different, right? So don't fall in that trap of that those b values are going to be the same, okay? The other thing I want to point out about standard form, kind of one of its quirks, is the reason why these are all capital is because they represent integers. So standard form will not have any decimals or fractions. Okay? Standard form cannot have any decimals or fractions. Okay? They're capital letters because they are all integer values. So depending on what you start with, converting an equation into standard form might be more work than others, just because if you have decimals or fractions to start with, then you'll have to do some extra stuff. I'm going to scroll down a little bit so we can have more work down here on these three. Does anyone else have any questions or need more time for notes up here? Okay. So our first task here is to convert from slope-intercept form to standard form. Okay. And like we said earlier, the only difference between slope-intercept and standard form is that standard form, the x variable is on the same side as y. So your first step is always going to be move the x term to other side of equation using opposite operations. Okay. The keynote difference between standard form and slope-intercept form is that the x and the y are on the same side. So if we start in the slope-intercept form where they're on opposite sides, we just have to move that x over. Okay? And we do that using opposite operations. So in this first one here, y equals 4x plus 7, what are we going to do that 4x term, that positive 4x term, to move it over to the left side? Noah? Say it. You just mouthed it. You were correct. Okay? How do you move a positive 4x using opposite operations to the other side? Subtract, right? If we want to move this 4x over, and this kind of goes right in line with PO7 where we have variables on both sides. If you want to move a variable term over to the other, you do the opposite operations. We have positive 4x's on the right, so we're going to subtract 4x's from both sides and move it over. Okay? 4x minus 4x, the reason why we always do opposite operations is to cancel terms out. So on the right side, they cancel out. We're left with 7. Now on the left side, we can't combine x and y because they're different variables. So we're going to put that negative 4x out in front because in standard form, right, ax plus by equals c, that x term comes first. So negative 4x plus y equals 7. And we're done. Okay, we have converted that equation into standard form. And the only thing we needed to do in this case was to move that x term to the other side using opposite operations. Okay. Questions on that? Okay. The second one, we've got a fraction there, which we know is going to be a problem at some point, but not yet. Our first step is still going to be the same thing. We're going to move that x term over to the other side. So since it's a positive 3/2 x on the right, what are we going to be doing to move it over? Subtract. Okay? Subtract 3/2 x. Your first step is always the same, regardless of what the equation looks like. You're going to move that x term over using opposite operations. On the right side, these cancel out, as they're designed to do. And don't forget about that subtraction sign. It does belong to the 5. So when we write our next line here, it is going to be a negative 5. It's a minus sign that also belongs to the constant there. And then on the left side, we subtracted 3/2 x. That's going to come first. And then plus y equals negative 5. Okay? That fraction poses a little bit of a problem because up above in our notes we wrote that you can't have any decimals or fractions. So what do we do? Think about your algebra skills here. What do we do to a fraction to turn it into an integer? Or essentially get rid of the denominator of that fraction. Not going to be dividing here. I mean, you could write it as division, but more commonly. Since the denominator of our fraction is 2, we're going to multiply by 2. Okay? So step 2, which you only need to do if necessary, which in this case it is because we have that fraction. So if necessary, you're going to multiply every term by the denominator or, and I'm going to keep that blank for now because we're going to fill in the rest of step 2 once we get to the third one, because you can see how that one's different from our previous 2. Okay, but for right now, if necessary, multiply every term by the denominator. So we're going to multiply everything by 2. Okay, because what happens when we do this here, I'll kind of do the math over here. We've got negative 3/2 times 2 over 1. What's going to happen to those 2's? Think about how you were taught to simplify fractions when you're multiplying. Okay? These 2's are going to cancel out, right? If you actually multiply it out, so we have negative 3/2 times 2 over 1, and you actually multiply straight across, and you get negative 6 over 2. What does negative 6 divided by 2 equal? Negative 3. right? The same thing we would get if those 2's cancel out. So to turn a fraction into an integer, you're going to be multiplying by the denominator. So multiply by 2 here. We have to multiply every term by 2 then. Okay? If we only do it to one piece of it, then it changes the value of the fraction, makes our balance uneven, and it's just problems. Okay? So multiplying by 2 is going to cancel out our denominator, leave us with a negative 3x. Y times 2 is now 2y, and negative 5 times 2 is negative 10. So this would be our equation in standard form. Okay. Last class is like, why would we even, what's so great about standard form that we want to know how to get there? Okay. And what standard form does, slope-intercept form, as we saw last year with graphing, it gives us the slope, gives us the y-intercept. We can graph an equation very, very easily. It tells us how this line moves and everything like that. Standard form, this is really good for identifying the x-intercept and the y-intercept of a given line, kind of like the zeros of it. Because most of the time when you graph stuff, you're only kind of dealing with that top right quadrant of the coordinate plane. And so oftentimes you care about these values here. You know, what's the x-intercept and what's the y-intercept? What's my bottom out? What's my high, right? And this form makes that a lot easier than the slope-intercept form does. So that's why we care, okay? Or why you might care. Maybe you don't care. The last one. What's different about the last one than the other two? What's different about the last one than the other two? Yeah. It's got 2 fractions. Okay. So in the first example here, we only had to do step 1 because there were no fractions. In the second example, we had to do step 2. We multiplied by the denominator of that one fraction. The third one, we've got to deal with 2 of them. But our first step doesn't change. Our first step, move the x term to the other side using opposite operations. What are we going to do here to move that negative 4/5 over? What are we going to do to move that negative 4/5 x over to the other side? What is the opposite of a negative 4/5? Yvonne?
Positive one.
Positive, right? So we're going to be adding 4/5 x to both sides. Okay? On the right side, as we want to happen, we're going to cancel out. That leaves us with 4/5 x plus y equals, don't forget about that subtraction sign, right? It belongs to the negative 3/10 equals negative 3/10. Everyone good so far? Questions? That first step we did is the same first step that we did for all of them. Move that x term over, use opposite operations. If most people get this one wrong because they forget the opposite operations, they take this negative 4/5 x and they write negative 4/5 x plus y equals r, right? They just move it over. No, you have to do it using opposite operations. Otherwise, your balance is going to be off, okay? So now, step 2, if necessary, multiply every term by the denominator, or what do we do if we have 2 different denominators here? What can we multiply by to turn them both into integers? Any idea? If you have more than one denominator, you're going to multiply by the least common multiple of the denominators. Okay? Since we have 2 denominators here, we have to multiply by the least common multiple. Which, the least common multiple of 5 and 10, right? That's what we're looking at here. Our 5 and our 10. What's the LCM of 5 and 10? What's the smallest number that both 5 and 10 can go into? Jacob? Don't think factors here. Don't think factors. That'd be factors. That's what goes into 5 and 10. What can 5 and 10 go into? Like if you start counting by 5s, 5, 10, 15, 20, start counting by 10, 10, 20, 30, 40. What's the first number that shows up in both lists?
10.
10, right? 10. So we're going to multiply everything by 10. Okay? Times 10, times 10, times 10. Because what's going on here, I'll take this 4/5 times 10. Okay? If you multiply that straight across, 4 times 10 equals 40. 5 times 1 equals 5. What's 40 divided by 5? An integer, right? 8. Yay! Okay? You can also kind of think about it mentally, like what's 4/5 of 10? 4/5 times 10. 4/5 of 10 gives us 8. Okay? So we're going to get an 8 here. Y times 10 is 10y. And then -3/10 times 10. Here, since the denominator is the same as what we're multiplying by, here they just cancel out. And we're left with -3. And so this would be our equation in standard form. 8x plus 10y equals -3. Okay? So you kind of have 3 different circumstances here. 3 different things your equations could look like. 1, there are no fractions to start with, so you only have to do step 1 and you're done. Okay? Second type, you got 1 fraction, which means once you move the x term over, you just multiply by the denominator of that fraction, and then you're good. The third type, you've got multiple fractions. Again, start by moving that x term over. That's always your first step. Move that x term over, and then here you are multiplying by the least common multiple of the denominators that you have. Okay? Buffer day, we're already going to use it here. Your homework is going to be to finish this first page only. We'll start the second page tomorrow. Okay? Finish this first page only. Take a look at the other, I know there are 6 that you have to do. Right? 6, or are there more? 6? What's one you'd like to do together? We've got these 6 left for you to do for tomorrow. Morgan.
The second to last one?
Second to last one. So I'm only going to do one of these double fraction ones because I want you to try one independently. So we'll do this one, and then the last one will be left for you to do on your own. So y equals 7/6 x minus 1/4. We see that we've got the 2 fractions. Our first step, though, is always the same. We're going to move that x term over by using opposite operations. So minus 7/6 x from both sides. On the right, it cancels out. On the left, we've got negative 7/6 x plus y equals negative 1/4. Negative 7/6 x plus y equals negative 1/4. Again, make sure you've got that negative sign there of that negative 1/4. Now, we've got the 2 fractions, so we have to kind of go to that last part of rule 2, or of step 2, which is multiply by the least common multiple of our denominators. What's the least common multiple of 6 and 4? Again, 2 would be the greatest common factor. I'm looking for what's the first number, the smallest number that 6 and 4 can go into. You start counting by 4s, start counting by 6s. What comes up first? Sasha? 12. Okay? 12 is the least common multiple, so 12 is what we're going to be multiplying each term by. Okay? What that looks like here, that negative 7/6 times 12 over 1. Color ways you can think about it, but just multiply it straight across. Negative 7 times 12 is negative 84. 6 times 1 is 6. What's negative 84 divided by 6?
Couldn't you cross that?
Yes, you can. Yep, yeah, there are multiple ways to think about this. Yes, you can simplify here. You can think about it as 7/6 of 12. Yep, there's lots of ways to go. Okay, but the way that I showed, what's negative 84 divided by 6? Negative 14. Okay, so negative 14x, and then plus 12y. Okay. And then negative 1/4 times 12. What's a fourth of 12? What's a fourth of it? You divide 12 into 4 groups. You take one of those groups. How many things did you take? Noah? 3. Okay. So minus 3. And here would be your equation in standard form. Okay. Questions on that one? This type is obviously the hardest, right? It's got the most steps to it, the most stuff to think about. So the other one that's like it, you can do on your own, okay? But you've got 2 examples to follow here. And then plus the written out step of multiply by that least common denominator. What's another one you want to do? We have time for one more together, if you want. No? Yvonne?
The last one.
We're not gonna do that one because it's the same type as the one we just did. It's the only other type like that. I want you to practice that. So I'm gonna save the last one for you. So any others? On your homework, you do need to show your work. Okay? You have to show me. I mean, maybe some of you can do this mentally. I think most of us can't, just because there's a lot of steps. So I do need to see the work shown. Even if you can do it mentally, I need to see the work shown. Yes, fine.
First one, last row.
First one, last row. Y equals negative 2/7 x plus 10. We're going to start by using opposite operations. Move that 2/7 x over to 2/7 x plus y equals 10. Okay, make sure you are using opposite operations. Make sure you are using opposite operations. What are we going to multiply by? Kira, what are we going to be multiplying by to get rid of this fraction here? We're on 2/7 x plus y equals 10. Yes, 7. There's only one fraction, so we only have to look at the denominator of that fraction. These will automatically cancel out. Okay? And we're left with 2x plus 7y equals 70. That would be our final answer. Okay? All right, homework for tomorrow. Finish the page. Make sure you show your work. That's how you math. Don't forget to like and subscribe.